And we'll use the factor theorem to factor polynomials. And at the top of the page here it says if p of b, p stands for a polynomial, we'll call p of x. If p of b equals 0, remember that's the remainder in the division by x minus b. If the remainder is 0, that means that x minus b, whatever number b is a factor of the original polynomial. And we'll use this idea to factor a couple of algebraic expressions. And the first one we're asked to factor is 3x cubed minus x squared minus 10x plus 8. And the possible factors are x minus a constant, and that constant will likely be a factor of 8, the constant on the end here. So the numbers that we would try to find numbers that the division gives a remainder of 0 are factors of 8. And of course the factors of 8 are plus or minus 1, 2, 4, and 8. So actually 8 has 8 factors. And you just search for numbers that give a remainder of 0. For example, we could try to see if p of 2 has a remainder of 0, which means that we're looking to see if x minus 2 is a factor of this polynomial. So if we fill 2 in, we go 3 times 2 cubed, and that's 24, because 2 cubed is 8, times 3 is 24. 2 squared is 4, 10 times 2 is 20, and plus 8. And that works out to be a value of 8. So the fact that it's not 0 means that p of 2 is 8. The remainder is not 0. So x minus 2 is not a factor of this polynomial. Now we could have found that remainder by using synthetic division. So you could have done the same thing with synthetic division. Of course, we found p of 2 is 8 here, so we'd be putting a 2 here. And so bring the 3 down. And go again, 2 times 3 is 6, so we have a 6 here. Negative 1 and 6 add to 5. And 5 times 2 is 10. Negative 10 and 10 add to 0. 0 times 2 is, of course, 0. And 8 and 0 add to 8. So there's the same remainder. We could have found that the remainder isn't 0 using synthetic division, or even long division, I suppose, as well. Now, so you continue to search for numbers that do give a remainder of 0. For example, another factor of 8 is 1. 1 is another number in this list, so we could try 1. Or you could graph 3x cubed minus x squared minus 10x plus 8, and notice that one of the x-intercept is 1. And so we bring the 3 down and multiply it by the 1, so 1 times 3 is 3. Negative 1 and 3 add to 2. And 1 times 2 is 2, so we put a 2 here below the negative 10. Negative 10 and 2 is negative 8, times the 1 is negative 8, and we get a remainder of 0. So that means that x minus 1 is a factor of this polynomial. Now when we divide x minus 1 into the polynomial, we're left with 3x squared plus 2x minus 8. So we still have to factor the 3x squared plus 2x minus 8. And you actually could do another synthetic division. That's one of the nice things about synthetic division. If you know another number, or you want to check another number to see if you get a remainder of 0, you can actually just do the division with the remaining numbers here, the 3, 2, negative 8. And another number in this list of numbers is negative 2. We showed that 2 didn't work, but negative 2 actually does. Bring the 3 down, multiply by the negative 2. Of course, that's negative 6. 2 and negative 6 add to negative 4, and negative 4 times negative 2 is 8, and negative 8 and 8 add to 0. So we have a remainder 0. So negative 2 works, so x plus 2 is a factor. So because we got 0 remainders in both of these, that means that our original polynomial factored into, now a 1 worked, so that means that x minus 1 is a factor. Negative 2 worked, so that means that x plus 2 is a factor. And the 3, negative 4 is the last factor. That means 3x minus 4 is the third and final factor. And so there we have this cubic fully factored. It has 3 linear factors. Flipping over to the second page, and this is another statement of the factor theorem. It doesn't always have to be a whole number here that the remainder in the division is 0. P of b over a, if p of b over a equals 0, that means that ax minus b is a factor of p of x. Remember, this is really the restriction in the division. If we were to do this division for ax minus b, and so if we have ax minus b cannot equal 0. If we solve for x, ax is not allowed to equal b, and so dividing the a out, we get x cannot equal b over a. So if ax minus b is the factor we're referring to, then that's why we're trying b over a in the polynomial. So, on to the example. Now, so that means that in order to factor this, we don't just have to look at factors of 12, but actually 12 over the leading coefficient 2. And the factors of 12 are 1, 2, 3, 4, 6, and 12, plus or minus, and the factors of 2 are plus or minus 1 and plus or minus 2. And so if you actually take a look at all of these factors over the plus or minus 1 or plus minus 2, this is what you would end up with. It's a pretty exhaustive list. For example, plus or minus 1 over plus or minus 1 is actually plus or minus 1. Plus or minus 1 over plus or minus 2 is actually the plus or minus 1/2. For example, the plus or minus 4 over the plus or minus 1 is the plus or minus 4 here. Right down the last, plus or minus 12 over positive or negative 12, of course, is positive or negative 12. So there's actually a lot of different numbers you could theoretically try here. So you would search for numbers that do actually give you a remainder of 0. For example, one of those numbers is 3/2, and there actually are whole numbers that will work here, but because we're talking about the remainder theorem, if we have a fraction here, a rational number, I'm going to show that 3/2 actually can work here. And so remember, we bring the 2 down, and so we multiply that 2 by the 3/2. Remember, that looks like this. So we have 3/2 times 2. Remember, the 2's divide out. 2 goes into 2 once, so 3 times 1 is 3. And so we add -9 and 3 and get -6. So now we need to multiply 3/2 by -6. And the 2 goes into itself once, and the -6 -3 times. So 3 times -3 is -9. And so we add that to the 1 and get -8. So one last time, we'll go 3/2 times that -8. And so 2 goes into -8, -4 times, and so 3 times -4 is -12. And we do get a remainder of 0. And so we have factored this polynomial. That's our original polynomial. And remember, the 3/2 means it's actually x minus 3/2, and the 2, -6, -8 is 2x squared minus 6x minus 8. And remember, what you do here to actually get the factor that doesn't have a fraction in it, the ax minus b factor, is you common factor a 2. Notice there's a common factor of 2 in this trinomial. So we factor the 2 out of there and multiply that 2 by the x minus 3/2. So multiplying the 2 by the x gives us 2x, and multiplying the 2 by the 3/2, the 2's divide out and you're left with a -3 here. And so we have then x squared minus 3x minus 4. Now we still have this trinomial to factor, and we could actually just say, well, what adds to -3 multiplies to -4, or you could use synthetic division with the 1, -3, -4. And for example, -1 actually does work with this. So we bring the 1 down. Most people wouldn't use the synthetic division here because it is pretty easy to factor this, but it can work. -1 times 1 is, of course, -1. -3 and -1 add to -4. And -4 times -1 is +4. And so adding that to the -4 above, we get a remainder of 0. And so we have the 2x minus 3 factor. The -1 worked, so that means that x plus 1 is a factor, and the 1, -4 at the bottom is the other factor, 1x minus 4, or x minus 4. But also, you don't have to do this synthetic division. We could go on back here and say what adds to -3 multiplies to -4, which is 1 and -4. So you could have factored that way as well. But anyway, those are the 3 linear factors of 2x cubed minus 9x squared plus x plus 12. And so that's factored using the factor theorem. And that's the end of the lesson.